Good afternoon or morning, depending when you're watching this. This is Professor Elliott again, and let's take a look at basic Zener diode calculations. Okay, Zener parameters. Okay, so just some basic terminology. The Zener voltage, nominal Zener voltage, this is what the data sheet says it should be, is Vz. IZT is the Zener test current. ZZ is the Zener impedance. IZM is the maximum Zener current. This is the formula. You take the power dissipation divided by the Zener voltage. Unless you're told otherwise, the power dissipation is 1 watt. Okay, that you have to calculate. It's not on a data sheet. And IZK is the Zener knee current. So IZK, the Zener knee current, is the minimum Zener current required for proper operation. IZM is the maximum Zener current. If you exceed that, it'll get too hot and it'll basically go up in smoke. Okay, so from a Zener diode data sheet, which I have provided for you elsewhere, we pick the Zener diode. So Vz, the nominal Zener voltage, 24 volts at a Zener test current of 10.5 milliamps. That's how it's understood. So if you change the Zener current up or down, you're going to slightly change the Zener voltage. Okay, so we're going to go with a 30 volt battery without that Zener diode, 24 volt Zener with those parameters. Okay, Zener diode curve. Okay, so this is the forward part of the curve. The Zener diode acts like a normal diode when forward biased. If we're going to use it as a Zener, we shall reverse bias it, so I'm just focusing on that. Okay, so this is IZK. This is the knee of the curve. This is where it's starting to exhibit Zener action. Zener test current. Okay, so this is the 10.5 milliamps. IZM, you have to calculate this. Out. I get my pen to work. So this is going to be, sorry about that, not sure why it's not picking up. Anyway, so this is going to be the 1 watt divided by the Zener voltage. We're going to work it out on another slide, but anyway, that's the formula, which is the same one that I gave you there. Okay, so at IZT, at the 10.5 milliamps, this is the Zener voltage, the green line, the nominal voltage. So can you see that at the Zener current, because this is a slope line here, Zener current is going to cause the Zener voltage to be a little less than 24, and at IZM, the Zener voltage is going to be a little more than 24. I think if you study that, you'll find that's pretty obvious. Okay, so let's go ahead and solve the thing. So we want to solve for the value of resistor R. Okay, R is going to limit the current through the Zener to IZM so it doesn't overheat. And then we're going to calculate the minimum value of RL. So what's the minimum or smallest value of RL? In which case the Zener still continues to work. Okay, so there's the Zener currents. Right, we have IZ, we have the low current IL, IR is just the combination of the two. So this is really a very simple series parallel circuit. Okay, and there's the current relationships. Okay, value of series resistor R, memory concept. What size of resistor is needed to allow current IZM to flow through the Zener? Okay, back to the exact same circuit. Now in this case, we have to mentally disconnect, remove RL. So I'm just going to go ahead and just erase it away like that. And when I erase it away, now we have just a simple series circuit where the Zener current is the same as the resistor current, And if we set this to 30 volts, and this was our 24 volt Zener, what value of resistor current here will limit this to IZM? That's the problem. Okay, here's all the formulas. First thing you want to calculate is IZM. Okay, IZM is PD max, 1 watt, divided by VZ, 24 volts, is 41.67 milliamps. The change in the Zener current from IZM to IZT, because IZT corresponds to 24 volts. That's where we know the voltage is. So if you subtract then those two numbers, you get the 31.17 milliamps. The change in the Zener voltage is equal to the change in the Zener current times ZZ, 0.77925. Go back to the Zener curve. Okay, you'll see because of the slope of the line, then because we're increasing the current from IZM to IZT, we're going to add the delta VZ. So this is going to be 24.78. So if we go back to the graph, okay, so I'm just going to erase this here. So this is going to be 24.78. Corresponds to there. It corresponds to that. All right. Go back again. One more. Okay. So from that, then we got to figure out the voltage across series resistor R. It's this E minus VZ. It's this number here. And then R is VR divided by IZM. It's just Ohm's law. Is 125 ohms. So I've just summarized all that for you there. So there's the currents, there's the value of R, and there's the voltages. Okay, so help you put it all together for you. Okay. The minimum value of RL, memory concept. What size of resistor will allow current IZK to flow through the Zener? If RL becomes too small, the load current is too high, IZ maybe fall below IZK, and the Zener's not going to work right. Okay, so we've restored our RL. Okay, and we want to figure out what's the minimum size of that resistance. Okay, let the Zener current equal IZK. That's going to be this number right there. Okay, it's essentially the same formulas as before. The change in Zener current from IZT to IZK is 10.25. The change in Zener voltage is the change in Zener current times the Zener impedance, 0.2565. Okay. Now we're going from IZT to IZK. We're going down in current, so we're subtracting and not adding. So this is 23.74. Go back to our curve. Okay. Can you erase that? Okay. So this is going to be 23.74. That's the voltage right there, and that corresponds to IZK. Alright, so therefore, okay, so we got that. Okay, VR is E, which is 30, minus VZ. IR is VR divided by R. IL max is IR minus IZK. And RL min is VZ divided by IL. It's just Ohm's law. Okay. You also check on my other professor notes. I have typed examples on that you're welcome to print out and review. Okay, so I put all the values there. So VR is simply that minus the VZ gives us this, right? And that divided by the resistance gives you the current. So if we have 50 milliamps there, and we need 0.25 milliamps there, that leaves us 49.83 milliamps there. Divide it into the Zener voltage, is you get a rounded answer of 477 ohms. Okay, that's it. Thanks for watching, and I hope this was beneficial to you. Great, and see everybody soon. Bye-bye.